right, an ellipse is another conic. The ellipse is defined as the collection of points in a plane when you add the distance from two fixed points on the plane we call these the foci, plural of focus, and that sum is a constant. So I have a curve, I have 2 points, and I have a distance and a distance, this distance and this distance. And I can move this around the curve, and no matter where I go, if I add these two distances up, it's the same number. So let's look at an ellipse. I have an ellipse. I have 2 points here. These are called the vertices. I have a point here, that's my center, and along here I have my foci. So all along here, this is called the major axis. And I actually also have some points here, and this is called the minor axis. And we say the distance of the major axis is 2a. It's a from the center to one focus. And the distance of the minor axis is 2b. And the distance from the center to the focus here, that's c. So from focus to focus, it's 2c. And I can have one that looks like this, or I can have one that looks like this, and then my vertices would be here, my center, and my foci. So you'll notice that the major axis can either be in the x or y direction. And this distance, the major axis is still 2a, so if it's in the y direction, then this distance is a. If it's in the x direction, this distance is a. And we'll see that from our equations. So if I have one that's in the x direction, my equation looks like this. And then my center is at hk, okay, equals 1. And there's a relationship that says that a squared minus b squared equals c squared. So a is bigger than b every time. A is bigger than b. And it's also, a is also bigger than c. And this happens for both equations. So here my major axis is in the x direction because a is bigger and it's under the x value. And if my major axis is in the y direction, here's my equation. And here a is bigger. This is still the same. This holds for both of them, these relationships. And it's just that whichever the major axis is, that variable is over the larger number. I also have something called an eccentricity. And that's E, and it's defined as C over A. And since C is always less than A, it's always going to be less than 1. Okay? But when I look at E, if E is close to 0, then it looks like a circle. So if it's close to 0, that means that A is a lot bigger than C. So the foci are at the center. And if E is going towards 1, it's a line, because then my ellipse looks like this. It's looking like a line. It's getting very, very flat as E goes to 1. And that's about an ellipse, so I'll do some problems.